Right, carrying on from where we had just left off. So remember you had the fifth root of x. We changed that to x to the power of a fifth, right? Minus 3x to the power of 5 over 2. Having changed that, we now want to find the first derivative. Sorry. So take the x raised to the negative of fifth. You drop the negative 1 over 5, x to the power of minus 1 over 5 minus 1. Okay. Then with the second one, you keep the coefficient, it's negative 3. You drop the 5 over 2, x to the power of 5 over 2 minus 1. Okay, so now let us deal with the exponents. So the negative 1 over 5 minus 1, you now have negative 6 over 5. Do you guys agree with that? Yes, no, people?
Yes, ma'am.
All right.
Yes, ma'am.
Then minus 3 multiplied by 5 over 2. That is now minus 15 over 2. Okay. 5 over 2 minus 1. We're left with 3 over 2. Okay, second term, look at the second term. Is that correct? Yes, no?
Yes, ma'am.
Yes, ma'am.
Okay, so if they haven't explicitly stated that you should not leave your answer with negative exponents, okay, or if they said no negative exponents, okay, so if it's no negative exponents, we're going to have to change this one, okay? How would you change that? This would become negative 1 over 5 x to the power of 6 over 5. The second term just stays like that because that one doesn't have any negative exponents. Okay. All right. Any questions related to what we just did?
No.
Okay.
No, ma'am.
All right. Sorry, I was just letting people in. So now we've done this one. I want us to tackle the following question. Okay. Right. So the diagram below shows the graphs of f of x equals a to the power of x and g of x is bx squared. So you have an exponential function and you have a quadratic or a parabola here. The point P is 1.5. That's the point of intersection of both. Calculate the values of A and B, right? So I want to work out that first question. Any idea what I should do to work out A and B? So they've given us on the f of x graph, we have 2 points that we can work with. We have the 0 and 1, and we have this one, okay? So you can sub in the point 1.5 into f of x equals a to the power of x. Okay, so this is your x, this is your y. Right, 1/2 equals a to the power of 1. So straight away you can see that a is just equal to 1/2. Okay, so f of x is equal to 1/2 to the power of x. Now for g of x, we had bx squared. Again, you can use the same point, right? Where you see x, you just plug in 1. And where you see y, you plug in a half. So a half times b, x. So b is also equal to a half. Okay. So for g of x, your equation is a half x squared. So we've calculated the values of a and b. Now, write down the equation of f inverse, okay? So we're dealing with this one. F inverse in the form y equals ... 31.2. So they want us to write F inverse in the form y equals ... So this is for 3 marks, but usually I would give this like 1 or 2 marks. But since it's 3 marks, they want to see the following. So remember, whenever you're looking for an inverse, you start off at this point. What would the next step be? You would have to switch the x and the y. So here, you now have x equals a half to the power of y. To make this the subject of the formula, you take the log of both sides. So in the form y equals, this would be log to the base of a half x. Okay. Right, so for this one, you get a mark for doing the x and y and then positioning the log a half like that. And then for the entire equation, that would be your 3 marks. Okay. Just for practice, let us find the inverse of that. Okay, so taking the gx equals, so y equals a half x squared. We want to find the inverse of that. So step 1 is switch your x and y. So you end up with x equals a half y squared. Next step, you want to isolate your y. So since you were dividing by 2 or multiplying by a half, you're going to multiply both sides by 2 to get rid of this half here. So you end up with 2x equals y squared. The last step would be to take the square root of both sides. So y equals the square root, positive and negative, 2x. Okay, now I want to ask you 2 questions, right? So for this one, this was the inverse, okay, function. This here is the inverse of f. Remember, it was an exponential like that. Do you think the inverse, okay, of the f or f inverse, is this a function? Is this a function? Yes or no?
Yes, ma'am.
It is a function, okay? So it's a function because it passes the vertical line test and you get 1 x value gives you 1 y value, okay? So if you were to sketch that, what would it look like? Okay, remember you had this point here. This was 0 and 1. Then you had that point which was 1.5. If you were to sketch the inverse of this, remember the inverse, you always just switch the x and y. Right, so the new point here is going to be 1 and 0. Then what's the other one? Switching those two, you have a half and 1. So it's going to be somewhere here, a half and 1, somewhere there. Then you connect the 2 like that. Okay. And remember, it's a mirror image. Okay, well, I'm trying to draw a straight line that goes through the line y equals x. Okay, so that's a function and it is 1:1. Okay, so it is a function. Now think about this other one here. Would this one be a function? Now this whole thing here, is this a function?
No, ma'am.
It's not a function. Perfect. Why? Because, right, remember initially you had that. Okay, this was your half x squared. Right, what can I do to make this into a function? So as this is here, this is not a function, because if I were to sketch it, it would look like that. Okay, so this is not a function. Why? Because if we were to do the vertical line test like that, can you see for one x value, you get how many? You get 2 y values. So this is not a function. What can I do to make it into a function?
Add a restriction, yeah.
Right. So we're going to restrict the domain of g of x. Okay. By doing what? You either say x is greater than or equal to 0, or x is less than or equal to 0. So those are your two options. Okay. You can restrict the domain of g of x so that the inverse, g inverse x, is a function. Okay, so by doing what? By saying x is less than 0 or x is greater than 0. Now, if it wasn't centered, or if it didn't have the center or the turning point at 0. So let's take let's take x squared plus 2x plus 1. Right, this graph here. Okay, remember it's also a parabola. Okay, it's okay, someone just came in, and just mute your mic. We can hear everything. All right, so for this one, okay, it's also a parabola, but if you were to make this into an inverse, it wouldn't be an inverse straight away. We'd have to do something. Okay, to make it into an inverse, let us figure out what the turning point is. So how do we work out the turning point of a parabola? What is it? X equals?
Negative b over 2a.
Brilliant, negative b over 2a. So ax squared plus bx plus c. So negative b over 2 times a, which is 1 here. So the turning point is x is equal to negative 1. So that's the turning point here. X is negative 1. So we would have to restrict at this point. So you would say x is greater than or equal to negative 1, or x is less than or equal to negative 1. Why would we do that? To make g inverse x a function. Okay, awesome. That's what you do if you have a parabola. You look for the turning point, restrict it along that, okay? Those 2 points, either of those, to make g inverse a function. So let's go back to our question. So we've done that. Explain why g is not a function. Okay, we've also done this one. Okay, so in your answer, you would say g is not a function because it fails the vertical line test. You explain how it fails the vertical line test. For one x value, we get 2 y values. That's why it's not a function. And we've also done this. Write down 2 ways in which g in which the domain of G could be restricted in order to make G inverse a function. We've done that as well, okay? Determine the values of X for which F inverse X is greater than 0. Okay, so let me just get rid of this extra writing. I want you guys to look at 31.5a. We're going to answer that together in a bit. Okay. So determine the values, the X values for which F inverse X is greater than 0. Okay, so these are tricks and hints that I want to give you, right? Remember we said F inverse X is equal to log to the base of a half of X. They want you to determine the values of X for which this graph is greater than 0. Greater than 0, okay? We sketched it, and initially you had, so 0 and 1, 1 and 0. Then a half and 1 was the other point. So your graph looked something like that. So for determine the values of X for which F inverse is greater than 0. So looking at this sketch here, okay, which values are greater than 0? Another way, if you're stuck in your test or exam, put your calculator into table mode, okay, and plug this in here into your calculator. You create your table, your step is 0,5, okay? Your start point is 0, and then go up to 5. Then from that, you'll be able to see where you get values, Y values which are greater than 0. So looking at this sketch here, okay, there are certain values which are strictly greater than 0. Let's highlight the part of our graph which is above. So that's the part of our graph that's strictly above 0. Okay, now we need to see which are those Y values. It's the Y values between 0 and what? 1, right? So how would we express that in terms of an inequality? So X is between 0 and 1. Okay. Does this make sense? Yes, no?
Yes, ma'am.
Okay. All right. Then part B, write down a value of X for which F of X minus 1 equals G of X. So we want to look at this. F of X minus 1 equals G of X. I'm going to give you some time to think about how you're going to answer that. Okay, you could look at the graph, you could try and solve it. So we're looking for F of X minus 1 equals G of X. Okay, let's go and see our graph here. So F of X, I'll highlight the F of X. This is the F of X. If we were to subtract 1, okay, from it, if we were to subtract 1, where would it then be equal to? X. So basically, you're looking for a distance where distance between the two graphs, where you see 1. Let me show you what I mean. So another way of rewriting this would be F of X minus G of X is equal to 1. So I've rearranged that. I think you're more used to seeing this one, right? If I were to subtract the y values of f of x and the g values, if I were to subtract the two, where do you see a distance of 1 between them? Okay, so look at the graph. Where do you see a distance of 1?
Between
Ma'am, is it
the
on the y-axis?
theta and y-axis.
Okay, so what's the actual coordinate of x at that point?
0.
Perfect. It's here because at this point here, remember that point is 0 and 0, right? So the y value here is 1. So the distance between these two is 1. And this occurs when x is equal to 0. Okay, so this is like a problem solving type question. You would see it, you'd rearrange, okay? And then f of x minus g of x, look for where you have a distance of 1, x is equal to 0. Okay, awesome.